UFOs is something that has been in the news because there's so many people coming forward and saying they're whistleblowers and talking about their experiences. What once was kind of a fringe thing has become
normal.
Like we're all expecting it now, like, so this is a toy that I had from when I was a little kid. And I've noticed, as you have on yours there, they all have this shape, right? The saucer shape, where the term flying saucer came from. Why do you think it's that shape? And what could that possibly be doing for the functionality of a UFO?
Yeah, so to go back to Ken's shoulders with the exotic vacuum, objects, essentially, is that when you're trying to do a space-time charge or space charge polarization effect on the universe, you're trying to create more of a black hole type of situation, a dark hole. Because when you make a dark hole, electrons want to fall in and fill it, because nature hates a vacuum. She hates it. She will always fill it. And so what basically UAPs and plasmoids do is that they create a very special situation like Victor Schauberger, where they swirl the electrons into a situation where they lose their update function between the positron and the electron. And that in a normal mode situation in the universe where time is on point, it's 1 click, 2 click, 3. It's like gears going click, 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 click in a gear. But when you create these exotic vacuum objects with these transistors and special electronics, you can create the gear slippage. The gears will slip in the universe. The time frame gets kind of distorted and it gets missed. And then the quantum world starts becoming strange, where it's not just like, I've got a bag of M&Ms, but the bag of M&Ms will go through the table if I drop it, right? Like weird stuff starts happening.
Yeah, they say that the way the quantum world works is different than the world of matter. Like once you get small enough, the rules change and other things are possible.
Yeah, essentially as nuclear fusion can happen, nuclear transmutation can happen at room temperature. You can turn lead into gold at room temperature. These things start happening on a higher probability, right? Because in a normal situation where matter and antimatter, they're all stable. They're stabilized, right? But when you create the situation with your electronics where you destabilize the time frame between matter and antimatter, then you can have slippage. You can have magic happen. You can have, more energy out than you put in. You can have all these amazing things that nuclear fusion is supposed to do at room temperature that's safe nuclear. And that here at Quantum Kinetics, using the arc reactor fusion on demand technology, we are the first to fusion registered trademark as of February 10th.
That's awesome.
So congratulations, investors, and all you people that have helped out with Quantum Kinetics. We are dominating right now. It's That's amazing. Awesome. Our research verified, like you like to say.
I like to remind you to say it. Yeah.
I know.
Yeah. No, that's great. And I mean, I think that's something, we were talking about this in preparation for the show. When people think about, when any investor thinks about what it means to invest, myself included, because I am an investor.
Yes, you are.
And I said this the very first time, was that one of the things that I found compelling about a claim, because I'm an inventor too, I have a patent.
Yes, you are.
And
numbered notes.
Yeah, when you make a claim, it really forces you to be like, is this legit? Is what I'm claiming legit? And you have. One of the things I like to remind you of that's so special about this effort and this project and this business is first to fusion sustained how long?
So we are officially sustaining nuclear fusion in this room right now, and it's been going on for 12 months as officially.
Wow. Now that's shocking, because all the other claims are like 22 minutes and
couple seconds,
and that's awesome in a sense, right? Because they have a tokamak reactor or a stellarator or laser ignition,
inertial confinement,
or they shoot the penny thing at the vacuum ball thing.
So inertial confinement is where they take the spheroid ball, and it's like a tritium ball, and then they shoot lasers at it, 196, 998 lasers, and it bounces off the wall, and the X-rays are focused into the pellet, which then cause ignition at the National Ignition Center.
Right.
And so they use X-rays to do fusion. The X-ray, the lasers are not shooting X-ray lasers because, by the way, making an X-ray laser gun is literally like the hardest thing to do in physics. You can't, to make an X-ray laser diode is like impossible because of the size of it. It's like nanometer, 0.1 nanometer size. So when we have a device that actually emits X-rays as a beam of energy, like a gamma ray emitter, a gamma ray burst, dude, that's an amazing technology. The arc reactor is the pinnacle of nuclear fusion and diode science right now. And we're doing low-grade nuclear fusion right now in this room, and we're having a podcast. It's no big deal, right? Because it's safe.
Yeah.